Dear student, today I'm going to discuss some tricks which will help you in determining limiting reactant, which is the most precious, costly reactant in our reaction. Let us have some examples. How can you solve without uh, lengthy calculations to find your moles of reactant, which one is limiting reactant and which one is excess reactant, and which reactant is producing the desired number of moles of product, any of the product. If you are given the reactant, one reactant, you can determine the moles of the product. If you are given the moles of the product, you can determine which one is the limiting reactant, which one is the less reactant. Let us have some tricks so that you may determine the desired calculations. So there are different rules to check which one is your limited reactant without any calculations. If you are given different masses, either in different units, either in SI units, either in CGS system, either in American engineering unit system of units. Let us have some rule first. If you are given the two reactant, which also contain one is the excess reactant and one the limiting reactant, and both reactant have different masses. Let's suppose one have 50 kg and other reactant has 100 kg. Then you have to balance the chemical equation. After balancing the chemical equation, the reactant which has least stoichiometric coefficient, which has the least number of moles in the reaction, is automatically will become your limited reactant. So you do not have to proceed lengthy calculations. You can easily solve multiple choice questions. And second rule is that when you have the same masses of both of your reactants, then you can easily equalize the number of moles of both the reactants. After equalizing, the reactant which have least number of moles is your limiting reactant. And rule 3 is that the never can get confused that when your both reactants have the same masses, then they can never be both of the limited reactant. There will always be one less limited reactant and one will be excess reactant. Let us have rule 3. In rule 3, if you are if you have the two reactants and both have the same masses and both have the same number of coefficients, stoichiometric coefficient, number of moles in the balanced chemical equation, then the reactant which is producing least number of moles of the product, which is producing least number of mass of the product, will become your limiting reactant. Let us have try some examples related to these. First is that let's suppose you have to given the two reactant. One is magnesium bromide and second one is silver nitrate. Both reactants are reacting with each other. When 1 mole of magnesium bromide will react with 2 moles of silver nitrate, then it will form 2 moles of silver bromide and 1 mole of magnesium nitrate. Then now you are confused which one, either it is your magnesium bromide is your limited reactant, either your silver nitrate is your limited reactant, because both have the same masses, 50 gram. Then now first condition, as I have informed you, that the reactant which has the least number of moles in the balanced chemical equation will become your limited reactant. Let us try this rule. And second rule is that you have to find the number of moles of the both the reactants, and you have to equate the number of moles of both the reactant. Then the reactant which is producing least number of which have least number of moles of equalized moles, it will become your limited reactant. Rule number 3, when you start from the calculation, you are any of the reactant. Let's suppose you are starting from magnesium bromide, then calculate the any of the product. If and from the same method you start from another second reactant and produce the number of moles of the product. If both of the reactant, uh, one of the reactant is producing less number of product, then it will become your limited reactant. Let us try this rule. Assume first your magnesium bromide is limited reactant as we know that 50 gram of magnesium bromide is given in our question statement, and we know that 1 mole of any substance contains have equal the molecular weight of that substance. So 184.1 is molecular weight of magnesium bromide, and 1 mole of magnesium bromide as balanced chemical equation produces the 2 moles of silver bromide. As we are focusing on, we can focus on the one product, so we have to ignore this product. We are just focusing silver bromide, and after that you know that 1 mole of silver bromide contains 187.8 gram of silver bromide. So after solving simplification, this produce 102 gram of silver bromide. Now let's do second reactant, which is also limited reactant. We are assuming silver nitrate, our limited reactant, and we solve in the same method as now. Now we have 50 gram of silver nitrate, and we know that 169.9 gram of silver nitrate contains 1 mole of silver nitrate. As balanced chemical equation, 1 mole of silver nitrate will produce 2 moles of silver nitrate will produce 2 moles of silver bromide. So both have equalized. There is no difference between these, and we know that 1 mole of silver bromide contains 187.8 gram of silver bromide. It will produce 55.26 gram of silver bromide. So as we check, we can check that silver bromide is, in this case, silver bromide has 55.26 mass gram mass, and in the previous it has 102 gram silver bromide. So uh, as I have told you some basic rules, some tricks, that the reactant which is producing least number of mass of the product is your limited reactant. So magnesium bromide is producing double times the mass of the product. So our uh, guess is, which we have guessed earlier, that silver nitrate is our limited reactant, is our limited reactant in this scenario. Okay, thank you.